The first question is, show that the surface area of the hemisphere is given by A equal to 3 pi r square. Here is the hemisphere. Its total surface area is represented as 3 pi r square. How do we know that? Let's break it down. The total surface area is equal to the sum of two parts. The first part is the curved surface area, which is 2 pi r square. The second part is the base area, which is pi r square. So, the total surface area of the hemisphere is the sum of the curved surface area and the base area, giving us 3 pi r square.
Let's move to the next question, which is question B. The question asks us to find how fast is the volume changing when the surface area is 18 cm squared, which is we known as rate change of volume over with time. Okay, so now to find dV over dt, we need to use chain rule, which will start with dV and end with dt, which will be a dV over dr and dr over dt. So the total equation is dV over dt equals to dV over dr times with dr over dt. Now let's look at the equation and point out what info that already given. The question says that there are constant rate of 0.5 cm³ per second, which is dr over dt. So we already got what to sub in equation for dr over dt. Now we need to find dV over dr to complete the equation with numbers to sub. Let's take a look again at the equation. There's a hint that says volume of sphere is 4/3 pi r³, but in this case we don't have sphere, but we have hemisphere. So we need to divide the volume of sphere with 2 to have a volume for hemisphere, which will be 2/3 pi r³. Next step is we need to differentiate the volume to find rate of change of volume with respect to radius, which is dV over dr. Then after differentiate it, we will get 2 pi r square. So now we have all the things to sub into our chain rule equation to find our main problem, which is dV over dt. So it will be dV over dr, which is 2 pi r square times with dr over dt, which is 0.5. But now there's a variable r in the equation, which we need to find first so that we can have an answer. But where we can get r? From question B, it states that surface area is 18 cm square, which we can conclude that A equals to 18 cm square. As we know, A in this case is 3 pi r square, so that we can simultaneous it to be 3 pi r square equals to 18 cm square. Then we can find r, which we will get r equals to 1.38. Okay, so now we can substitute value of r into the equation, which will be 2 pi times with 1.38 square times with 0.5. Then calculate it using a calculator and we will get the final answer, which is 6 cm square per second.
For question C, the question are asking us to find rate of change of its area when the diameter is 4 cm and state the area are increasing or decreasing. From the question A, we can know that the surface area of hemisphere is equal to 3 pi r square. From the diameter given, we can find the radius, which is 4 divided by 2, and the answer is 2, which is the radius. Next, we need to differentiate the area 3 pi r square to get the rate change of area respect to radius, which is equal to 6 pi r. Then we use the chain rule to find the rate change of its area, which is dA over dr times dr over dt. So we substitute the dA over dr and dr over dt. There will be 6 pi 2 times 0.5. Lastly, we need to calculate using our calculator and get the final answer, which is 6 pi cm square over second. Don't forget to state that the area are increasing because 6 pi cm square over second is more than 0.